Good afternoon or good morning, depending on where you are. Thanks for making the time to join us on this webinar where we're going to talk about stormwater filtration. In terms of introduction, my name is Kwabnose. I've been in the water quality management space for about 15 years. Most of it has been with Hydro International, where I started as a research and development engineer, and currently I manage our product development team. Prior to that, did some monitoring of stormwater ponds as part of my master's program in civil and environmental engineering. And currently in my role at Hydro, I work with the business units to develop their product development needs, and then working with the development team, providing resources so that we can develop cutting edge products that support our business units, but more importantly, address the concerns of our end users in meeting water management goals. My email and my phone number are here, so feel free to send me an email or call me anytime after this webinar if there are any questions. For an overview, I'll spend a few minutes talking about Hydro International, who we are and what we do, and what are some of the regulatory drivers, generally in the stormwater space, but for filtration in particular. And then we'll dive into some of the treatment options that are available when we talk about filtration. And I'll harp a little bit on the value of maintenance, as it's an important piece to ensure that our systems work properly. And then at the end, I'll provide a little bit of detail about some of the things we're working on where we see opportunities for the industry to grow in ways that would enhance water quality management in general. So when you take Hydro International, we have about 200 plus employees. And in the US, we're based in Portland, Maine, which is where our US headquarters is and our stormwater division. We also have an office in Portland, Oregon, where our wastewater and CSO employees are managing headworks for wastewater treatment plants. We have a few offices in the United Kingdom, which also houses our global headquarters, providing water management for Europe. We have one office in Dubai and also in Australia. And as you can see at the bottom, we have installations in over 33 countries, and that's growing. Hydro's been around for over 40 years, and we have been in the water quality, water quantity space throughout this period. We pride ourselves in our origins coming from product development, research and development, and so you would find that the products and the services we provide are world-class, industry leading. Our separators and filters are all over the world. Lots of separator and filter installations in the US, in Canada, but also in places like New Zealand and Europe. And one of the things we like to also talk about is our best-in-class hydraulic laboratory housed here in our Portland facility, where with a 25,000-gallon tank, we're able to really hone in on our testing and ensure that the products that we are supplying are really fit for purpose. We augment this with some computational fluid dynamics so that we can do some rapid prototyping and engineer our products to be fit for purpose. When you take Hydro as a whole, what are the things that we are good at? These are listed on this slide. I'll just harp on a few. Stormwater management, which we're going to talk about a little bit, but we've been doing this since regulations have been in place, and the combination of our separators, our filters, and the services that we provide in maintenance make us really a strong partner to work with in stormwater management. We use the same principles when we go to water and wastewater treatment, where at the headworks we provide cutting edge products to support wastewater treatment plants. In the last few years, We've done quite a bit of work in industrial stormwater treatment, as there's been a lot of talk around that and regulations have been put in place. And more, we are also getting into hydrometry, monitoring, sort of smart techniques to understand how systems are performing and how we can help our end users meet their goals for water management. So in a gist, these are some of the things that we support. I mentioned that product development and R&D is at the heart of what we do. And one of the ways we do that is collaborating with research institutions, especially universities all around the world. So as you can see here in the US, we've partnered with universities like University of New Hampshire, where we've done some verification work. We're going to talk about the Up-Flo filter a little bit, which actually the development of that started at the University of Alabama with Professor Bob Pitt, and we got involved. So we've used research institutions for product development. Places like University of Florida, where over the last 2 years, we've done some monitoring, which has helped us in our regulatory approvals. But also we've worked with universities in the United Kingdom and other parts of Europe, finding professors who are doing leading research that are technological breakthroughs that we can capitalize on, and also getting product verification and certification to meet regulatory needs. And talking about regulations, these are some of our certifications around the world, different states, different agencies. We work with DOTs, municipalities, ecology departments, environmental groups, and the like. So all across the country, where regulations are in place, product certification is needed, you would find that our products and our services have been certified and can be supplied in those areas. Now, when we come to what we're talking about today, which is stormwater management with an emphasis on filtration, why do we do this at all? Well, back in the 70s, there was recognition that our water bodies were having pollutant issues, and these needed to be addressed. So the Clean Water Act was put in place, specific to stormwater management. In the late 80s, the permits came in place where if you're looking at anything beyond an acre for development, you have to have some form of stormwater management in place. So that created an industry, but it's all because when we talk about runoff from stormwater, a lot of sediments there, there are high level of associated pollutants with these sediments, and we need to take these out because the impacts on our water courses are significantly negative. In time, dissolved pollutants have also been added to the mix, some from agricultural runoff, but also from stormwater management in our urban areas. And so coming up with ways to take the nutrients and metals out before they run into our water bodies is also quite critical. Now, this is an interesting graphic, which I pulled from a report that was presented to the Maryland legislature. And it was looking at the Chesapeake Bay and the pollutants that get deposited into the Chesapeake Bay. As you can see from the different land use types on the left, there's agriculture, forest, but I've circled the stormwater one just to highlight the impact of urban stormwater runoff and the pollutants that come from this land use and its impact on our water courses in general. So if you take nitrogen, stormwater is the third highest land use that contributes to pollutant generation. When you look at phosphorus and sediment, it is second only to agricultural runoff. And this highlights that if we do a good job at stormwater management and take out the pollutants that are associated with them, we'll go a long way to address the health of our water bodies and the aquatic life that thrives in those environments. So stormwater management is a critical piece to ensuring our waters are healthy. So at this point, we'll take a quick poll just to get a sense of our audience and what all of us are engaged in. I'll be sharing the poll, which should come to you shortly, and if you can answer that, then we'll move on. Okay, I'll let this run for another 15 to 20 seconds or so, and we'll close the poll. Okay, thanks for the responses. We'll be closing the poll now. I presume you're seeing the results from the poll now. So on this webinar, we have about 60% of us who are using filters as a practice for stormwater management. So hopefully as we go through, we will get a few insights that will help us in being able to do that. And there's also 20% starting to see them being used. So we might get some few things here that would help us. Thanks for your participation. So what are the things that we target in stormwater treatment? When we looked at the Maryland report, we found that sediment is a major contributor of the pollutants generated from stormwater runoff in general. And this has given us a sense of the particle size distribution of these pollutants. So we start from gross solids all the way through to dissolved solids. Now, treatment goals determine what sort of system we need to get the level of treatment that we're looking for. So if you go to some places, gross solids is what they care about. So if you're looking to take out material that's more than 1,000 micron or so, a screen is probably appropriate to meet those regulatory requirements. When you're looking at coarse solids and some fine solids, the higher end of fine solids, hydrodynamic separators, vortex separators are useful. And then when you get into really fine solids, then you have things like filtration and other chemical processes being useful mechanisms. So this gives a broad spectrum based on regulatory needs. And in some jurisdictions, taking out 100 micron is adequate. So a separator would be useful, and there are a range of separators that address that. But today we want to focus on those finer particulates where filtration gives us some advantages over just regular settling. To talk a little bit about the filtration process, there are really three key mechanisms by which we're able to take particulates, metals, or nutrients out using the filtration process. The most widely used is mechanical separation or physical separation, as some might call it. And here we're looking at sedimentation, just regular settling, enabling us to take out those pollutants. But you also have straining, where as some of the pollutants starts to bed in, they're able to take other pollutants or sediments that are coming in to settle with it. And then you have adsorptive processes where pollutants attract other sediment that's coming in, and they fill the pore spaces that are coming in there. So this is really purely mechanical, and you're doing a lot of straining in here. We also have chemical filtration, where you are exchanging different ions, more applicable when we are looking at metals removal, copper, lead, zinc, and the like. And you can take out the lead and the zinc by exchanging them out for what you have in your media. And typically you have a little bit of contact time associated with this type of filtration to enable the chemical processes to take place. We also have biological processes at play, very common when we're talking about water treatment and wastewater treatment. We're seeing it come into play in stormwater management as well, where the plants are giving you some nutrient uptake. So rather than having them go into the water courses, the plants feed on them. But also you have microbial uptake, where the bacteria within the media matrix are eating up the nutrients and the metals such that they don't end up as pollutants. So we are recycling them into the food chain. What are the constraints and considerations we want to think through when we are looking at filtration? A key component here is head loss. As the charts to our right demonstrates, as you put in more flow through, you're driving up your head. And that's something you have to consider in your drainage network. How much head do you have in there? And would it be able to drive the flow that's required to meet regulatory requirements? And then surface area, very important when we talk about filtration. Really, that's how we even write out our equations. The more surface area we have, the higher the filtration rates, but also enables us to have more capacity to trap pollutants that are coming through. And once we get into dissolved components and taking those out, where we're talking about nutrients and metals, contact time becomes one area of concern as well, because we want to ensure we have enough contact time within the filtration matrix so that the pollutant of concern can be taken out. So as we go through, I'll make reference to these three, to some of the filtration products or processes that exist that we can use. So what are some of the filtration options that are available to us for stormwater management? Here we're looking at media filtration, and it's by far the most widely used form of filtration. I'm sure quite a few of us would be aware of things like the Austin sand filtration. This would be in our general design manuals when we're looking at filtration. These have been around for a long time, and actually they are the high end of sand filtration in terms of flow rates when we're looking at downflow filtration. So with this, you have your flow coming in. Your media is acting as a trap, a strainer for the pollutants that are coming in. You build your head over the media matrix. And as your media traps, the material becomes clogged. And every once in a while, the top 2 or 3 inches of the media needs to be scraped off and replaced, because that's where the bulk of the filtration is taking place. So surface area is a big issue here, because you want more surface area so you can treat a larger piece of property, and you can only do so much in terms of flow rate, so as it's fairly minimal. One of the downsides with this is that you're not using the entire bed of the media, but it's available to you. Over the last 10 years, as I mentioned, working with the University of Alabama, we have looked at Up-Flo filtration. And there are some key advantages in using Up-Flo filtration that enables you to pass higher flows without compromising on the quality of the effluent. And primarily what is happening here is your flow drops to the bottom of the sump, so your coarser solids are retained in the sump. That ensures that your media matrix doesn't have to deal with the coarse fraction of the material coming through. And then as the flow goes through the filter matrix, you get a little bit of breathing effect, such that you're using the entire media bed. So the depth of the media is being used, where you can see it a little bit as volumetric filtration and not just the surface area. So you're able to have smaller footprints and be able to provide the same level of filtration compared to sort of downflow filtration. So as I've already mentioned, you have multi-stage treatment because you can get your coarser solids out before things get into the filtration matrix. Some of the other advantages are a drain down that prevents the media from sitting in water between storm events. And because you are using the entire depth of the media bed, you have longer life and you have longer maintenance cycles. And for systems like this, you can have sort of simple maintenance because you can deal with the bags that are involved. From a head loss perspective, for these types of media filters, you're looking at a fixed head loss. So you start with a known head loss. As your media matrix begins to blind, you maintain the same head loss, but your filtration rates drop a little bit. When it comes to contact time, not really an issue if you're dealing with sediment, but if you're dealing with nutrients or you're dealing with metals, then you're going to slow your filtration rates so that you're able to capture those pollutants. When it comes to surface area, because you are using the entire media matrix, you're able to consolidate some of your space such that you don't need very large systems. Over the last few years, biofiltration has also become really important in terms of stormwater management. Just as with other media filters, there are non-proprietary options available like bioretention systems, which are very well suited when the land space is available or you're targeting specific pollutants and you have a specific media mix for that. Some proprietary systems are also available using special mixes that have been engineered with an understanding of the loading rates or the filtration rates to support the pollutants that need to be taken out. The thing with these systems is, effective as they are, because of the nature of the filtration, proprietary systems are usually loaded at rates that are lower than what you would see in the other media filter I mentioned about. And the primary reason is you're looking for some nutrient uptake, you're looking for some metals to be taken out, and so you lower your loading rates to be able to account for that. And they're well suited for when you have the land available, but when you have site constraints, you do have some challenges associated with them. But they're an option that are available and provide very good treatment and control. All of these that have been discussed up till now use media. And one of the things that we've spent quite a bit of time looking at in hydro is what media types give you the level of control that is required. And the charts you're seeing here are for turbidity from stormwater samples, and you're looking at the NTUs from the influent to the effluent. So these are different media mixes using column tests to identify how much control can you get in terms of reducing the concentrations that have come through. And as we can see, for some of these, you don't get very good control, and for others you do. So if we were to take the first one, which is loam, there are times when the NTUs are going up from influent to effluent, suggesting to us that it's not a good media when we are targeting sediment from stormwater runoff. There are others that are showing very good promise, like compost and sand. Consistently, you're seeing a reduction in the NTUs. You see that with sort of the zeolite and sand as well. And statistically, as we can see, usually when you have a P, which is 0.05, it means there's a significant difference between your influent rates and your effluent rates. And the media types that have shown to be effective are the ones that are showing those lower P ranges. So by doing this, we're able to determine what material is suitable for the pollutant of concern. Like I said, this happened to be sediment, but we've also used it quite a bit looking at industrial runoff as well. Typically, what we're doing here is we're working with a client right from the onset, understanding the pollutants of interest. And once we're aware of that, if they are able to, we'd ask them to send a stormwater sample. We'll put it through a column test, look at different media types based on what they want to remove, and give them some recommendations on what media would work, what sorts of flow rates would work for the control levels that they are looking at. And so this is one way we help our clients, but also as we've built a database around this, we're able to understand what media types, what loading rates would work best. And on the right is one of those sort of industrial installations where the media has been tailored to the client's needs. A third aspect in terms of options for filtration is using membrane filters. Within stormwater management, this is relatively new. I'd say it's been used over the last 5 to 6 years, but we're all aware of cartridge filters that have been used in pools or aquariums to keep them clean. And the reason why membrane filters are starting to be used in stormwater management as well is there are some areas where the level of treatment required is such that very, very fine particulates need to be taken out. And when you get into very, very fine particulates, media filtration becomes a bit of a challenge, because if you use a media that has very fine particles, you really restrict the flows you can put through. So with membrane filtration, what we're doing here is we're selecting a membrane that we know anything that exceeds the micron size or the opening of the mesh will be trapped. So as we've developed our filter range within Hydro, we've also looked at membrane filters, and within our range now, we have membrane filters to support those areas where fine particulate removal is required. So similar to the Up-Flo filter I shared earlier, with the system that we have, you also get that multi-stage where you're able to settle out your coarse particulates. And so your membrane only has to deal with the very fine particulates that come through the system. Again, the membrane can be tailored to the needs that are there. So if you're looking for 20 micron removal, you select a mesh that would provide that level of treatment at whatever percentage rates you're looking for. But when we talk about membrane filtration, one of the challenges there is you really need high surface areas, because it's basically a straining process. And so you're capturing everything that's coming through. It's going to blind relatively quickly. So by having a high surface area, you are providing more opportunity to trap sediment before you have to go through a maintenance cycle. You get very reliable performance, because anything that's larger in size than your mesh size, you're going to trap it. But like I said, surface area is a big issue here. You don't have to worry much about head loss on the onset, but then as your system begins to capture material and sediment gets trapped in there, then your head loss is going to build up very quickly. Another thing to mention about membrane filtration is, because it's really using just the mechanical process, if you're looking at any dissolved control in terms of your metals and your nutrients, you're not going to be able to get that with membrane filtration. So in a gist, we've talked about sort of 3 types of filtration that are available within the stormwater industry. And depending on sort of your needs, you can pick one of these and use those to address those needs. So now that we know a little bit about these aspects of filtration, we'll take another poll and see what we see as key areas that we need to address, or where we want to use our filters. So I'm launching another poll and would appreciate your responses. maybe another 30 seconds or so. Okay, we're going to close out the poll and share the results. So from our responses, looks like sediment is by far what we're looking to address. And with sediment, we can use any of the three filtration options that are available. And the key there is understanding, are we dealing with really fine sediment? Are we dealing with relatively coarse from a filtration standpoint? And when we're talking relatively coarse for filtration, we're talking about material that's maybe 20 to 50 micron in size. So that would impact what we choose. If it's really fine, we probably have to go the membrane route. But there, what we need to understand is that we're probably going to have systems that are little more largely sized to be able to accommodate the load that comes through. Thanks for your input again. And we have a little bit around nutrients and industrial contaminants. And so there again, you'll be looking at media filtration rather than membrane filtration. And we could use the bioretention systems as well to address those needs. So when we come up with all these products, how do we know that they work? Well, I mentioned at Hydro, we go through our processes, and so we understand exactly how our systems work. We're continuing to do research, and we refine our products, put in different media. But on a broader scale, there are agencies in North America that require products to be certified, verified, and we engage in these all the time. I think I shared one of the slides around that. But there are two in the US that stand out in terms of product testing and certification because they've become a little bit of a national program, if we could call them that. One of which is the Washington Department of Ecology through their TAPE program. And this is a field-based program where their interest is looking at sediment, nutrients, and metals. And for sediment, they're looking for 80% capture of sediments that come through the influent for the particle size that exists there. For nutrients and metals, the ratings are for 50% removal. And it requires full year monitoring so that you can get the longevity to understand how a system works. And one thing I would mention is that field testing is really challenging. So the benefit here is that you're able to understand the robustness of a system. But in terms of comparison between technologies, it's quite challenging because from site to site, the conditions will be different. And there are few agencies that look to what Washington does and uses those results to regulate proprietary systems. Also on the East Coast, there's the New Jersey Department of Environmental Protection Laboratory Protocol for stormwater control systems. This is a lab-based program. The advantage to this is that they have a very defined particle size distribution that every system gets tested by this. So it's in that sense, you can do apples to apples comparison. Looking for 80% capture of the test gradation. And there's a second component to the test where there is an exhaustion test, understanding when you put a system through how much sediment would it capture before a maintenance event is required. So seeing that quite a few of us are looking at sediment removal, sort of the New Jersey standard is a good one to look at from that perspective. And then the Washington standard adds to that from a longevity perspective under real world testing conditions. There's also a program up in Canada, an ISO certification for stormwater BMPs. We're involved in that as well. And that's also a good way for people in Canada to understand which products will provide the level of service that's required. So having said all of this, obviously these are only 3 agencies doing this. All across the country, different states, different counties, different cities also have their programs. And if there's no reciprocity with some of these that I've already mentioned, there are tests requirements that we have to go through, and we're able to do that with the resources that we have, knowing how our systems would perform. So we've talked a lot about filtration. We've talked about the regulatory environment. One key thing that we can't lose sight of is maintenance. And because filtration gives us sort of the most challenging environment working in terms of the pollutants we capture, maintenance becomes even more critical. This diagram sort of illustrates some of this, where you're looking at an Up-Flo filter. In this instance, it's been in operation for a while. Lots of material has been captured. If for some reason this system is not maintained, you have all of these pollutants staying in there. And if a huge storm comes through, you can see how all the work that has been done, right from the regulatory to the design to the supply installation of the product to trap these pollutants, goes to waste because a huge storm just blows everything out, puts it in the water courses. And if we think about the loading that such pollutants would put into those water courses, we probably would cause more harm than if we had let the pollutants go in without trapping them at all. So the issue of maintenance is critical. And as an industry, that's an area that we haven't done a very good job. But moving forward, we need to put emphasis on that to ensure that systems work as they should, first of all, but more importantly, that we are protecting the water courses for which the regulations were put in place. I'm just going to run through a few pictures about how you would do typical maintenance for one of these systems. So this is a system that's reached maintenance. You can see how there's a lot of material on the lids of the modules. I'm pretty sure that the media matrix has also captured quite a few pollutants, and then you have material in the sump as well. So if you were to come to this system and maintenance was needed, you just use hose to jet down the sediment that's been trapped on the tops into the sump. Use a vector track to pull out the solids. You open up the lids, take out the bags where the pollutants have been trapped. These bags would weigh no more than 50 pounds, most times less. So you have an individual with a harness, he's in there, he can take it out. You probably have a couple of people up there who can take the bags, drop them down, no big equipment required. And then you change out the media bags, put in a new set of bags, and wait for the next maintenance cycle. Depending on the land use requirements, could be 6 months, could be a year, could be something in between. But that's something that needs to be monitored. This is also looking at one of our industrial sites, before and after pictures. So you can see the filters have been really worked hard to get some good treatment. And then after the maintenance cycle, new bags have been placed in. There's been a bit of a wash down, and then you can follow through with the next one. I talked about sharing maybe a few opportunities, and at Hydro, as we continue to innovate and look at ways in which we can enhance the systems we provide and also manage water resources effectively, we're getting more and more into understanding how we can use telemetry to enhance the performance of our systems. So if we can see this diagram as sort of a schematic that we can use. You could see number one being a filter system. And in here, you'd have a data log or a sensor, depending on what you're looking to do. But that then takes data from system performance. This could be logged once a day, once a week. Again, it depends on what we're looking to do. And that gets transmitted to your computer, where you have software that does processing, provides alarms, gives information on sediment depth, filter health, things like that. So now you have actionable intelligence that you can then use to determine, is it time for us to make a change to the media pack or the membranes that we have in there? So once these become fully implemented within stormwater management, what we then get is beginning to get some value, because we go and maintain systems when they need to be maintained. And now we have scenarios where a system may not need to be maintained, but because we are maintaining on time, rather than knowing when it's actually needing maintenance, we go earlier than we should. And there are other instances where a system has clogged up, it's ready to be maintained, but because it's not time yet, we're not aware of that, and we haven't done the maintenance. So some of the material that's been captured has been lost. So this is an area of interest for us. We're doing some work around this. And if you're on this webinar and you're a municipality, or you have quite a number of systems, and you're looking for somebody to partner with on something like this, we would be interested in working with you, looking at ways in which we can move the industry forward using some of these systems. Some of the work we've done around this is looking at sensors within the media, understanding what's being trapped. You can look at things like depth of media, weight of media, and the like to get some assessment. Also putting data loggers into manholes, where you can look at depth of water in there to get a sense of head loss and its impact on performance of systems. So these are ongoing, as well as media studies to ensure that, again, we can provide the solutions that our clients need. Sort of in summarizing everything we've talked about today, regulations are increasingly targeting fine sediments. And as we get into fine sediments, filtration is a key component, because some of the practices we have with our separators are not able to take out fine sediments. But even when we get into filtration, there are things that we need to consider. What's the particle size we're looking to take out? If you're dealing with nutrients and metals, do we need some biological uptake? Do we need some ion exchange? How fine is the sediment? Those are the things that would influence what sort of filtration approach we take. Are we going to use media? Are we going to use membranes? And what sort of filtration rate are we going to target? And maintenance is a critical component to effective management. And so we can't neglect that. And anything we can do to put effective maintenance practices in place, those are critical. And we see that as a need. And that's a service that we provide to our end users, if it's going to be of benefit to them, or if they don't have one already in place. And advances in telemetry are creating opportunities, and the barriers to entry are a lot less now. And as we learn about this, it's something we are incorporating in our systems, and understanding how we can harvest that data to better understand how our products are working, how we can improve them, but also to ensure that our clients know exactly what they are getting in terms of system performance, and maintenance is taking place at the right time, so that the regulations that we are putting in place to manage stormwater are being enforced, and enforced the right way. So in thanking you for your time, there's a little bit of a post-webinar survey. If you could take a few minutes after this to fill that out, that's good feedback for us within the business. that we can use to enhance things that we provide. And as you can see on this slide, we would send out PDA certificates, and there's also an opportunity to win a $50 Amazon gift card by participating. Thanks again for your time, and I've shared my email address again. If there are any questions that you have, I'd address them, or sort of using the resources within the business and the knowledge that's available. If I can't address it, I'll find the right person who can address it, and we'll get back to you. So have a good afternoon, and thanks again for your time.